order to perform analysis on the bookshelf, I have opened Ansys Workbench. I am going to drag static structural onto this particular project schematic, and I am going to double click on engineering data. Here I need to add new material. I didn't have the name of the material, so I am going to give my own name for the material, say Rakesh. And once I have entered this particular material, I can go to linear elasticity and I can drag this isotropic elasticity onto this material, and then I am going to enter the value. As per the problem specification, our Young's modulus was 13.1 GPa, which means I can convert the GPa into pascals by multiplying it into 10 to the power of 9. So my value will be 13.1 E9. Then coming to the Poisson's ratio, our value is 0.29. So once I have given this property values, I am going to close this engineering data manager. And now what I am going to do is I am going to select the geometry, and then I am going to just right click on the geometry, say import geometry, and I can browse and I am going to select this bookshelf option. Once I have imported the geometry into the design modeler, I am going to just right click on the geometry cell and I am going to ask to edit the geometry, because what the geometry I have taken is in 3D and I should be converting it into 2D. As I have told you, in this tutorial we are going to use the option known as the midplane option to reduce or to convert this 3D to 2D. So once I have opened design modeler, it asks me to regenerate this particular geometry. So I am going to right click here and say generate, and once I generate, this particular object has been successfully imported into design modeler. Now what I am going to do is, first of all I am going to set my units to millimeters. So it is not necessary at this particular point, but it is always good to check the units first. Then I am going to just go to view and I am going to just switch off the frozen body transparency. So this is the solid body. Now I need to convert it into say 2D body or surface body. Then for that purpose, what I am going to do is I am going to go to the tools, and in the tools I am going to select the mid surface option. And as I have showed you before in the design modeler tutorial section, how to select the different face pairs so that a midplane will be created at the exact middle of these two planar faces. So see here, see I am going to select this face, and by pressing Ctrl I am going to select this face. Then once again I am going to select this face and I am going to select this face, and then coming to this I am going to select this face as well as this face, and then I am going to select this face as well as this face. So here I need to select planar faces in pairs, then only the midplane option will be able to generate and create a surface. So I am going to just select this surface and I am going to select this surface. Once again I am going to select this surface and I am going to select this surface, and then I am going to select this surface, and once again I am going to select this surface, and see I am going to select this surface and this surface. And remember, we need to select all the surfaces by pressing down the control button. So without that you won't be able to select multiple options. So I have finished applying. So a total of 11 face pairs were detected by the computer, and once I have done this thing, I am going to just right click, say generate, so that the total body or the solid body will be converted into a 2D surface body. And remember, this particular option holds good for the bodies where there are lot of planar faces. You can use it even for circular faces, but it holds more good. It is more applicable to the objects which have planar faces. So once we have converted this into 2D, what we can do is we can just close this design modeler and then just open Ansys mechanical. So I am going to double click on the model, and this opens my Ansys mechanical. So once I open this particular mechanical one, now what I need to do is I need to fix the bottom surface. So for that purpose I am going to select insert, say fixed support, okay, no problem. We can even select the displacement and constrain all these particular motion. So I am going to select these two surfaces and I am going to apply and say 0, enter 0 here, enter 0 here, and enter 0 here, so that this particular displacement constraints will be acting as a fixed constraint. Then Coming to the loads, I am going to right click on the static structure, say insert, and I am going to select insert, and I am going to select this surface as well as this surface and apply. Now going to enter a value of 0.5 MPa as specified in our problem. So once I have done this particular applied this particular pressure value, I am going to right click and say solve, and once I solve, I am going to get the equivalent stresses as well as this particular say deformations and other sorts of things. So it is saying there is a large deformation. You need not worry, because what happens is our computer has detected due to the applied load there was a very excessive deformation that has occurred inside the body. We'll see what is happening. So I'm going to insert say deformation, and I'm going to say total deformation, and I'm going to just evaluate the results, and see here there was a deformation of 504 mm. That means even though the software is not able to represent the breakage, but in real case what happens, if we get 504 mm for this particular structure, it has failed far before itself. So one thing you need to do is you need to redesign the total structure, or otherwise what you need to do is you need to just reduce the amount of load. So for example, if I reduce the load by 10 times 0.05, and I am going to right click, say I am going to just solve the problem once again, and then see the deformation, total deformation was around 50 mm. Even though if the deformation was around 50 mm, no possibility that this design is going to work to bear such amount of load. So we need to redesign the total system. So this is how we can use the options present inside Ansys Workbench to convert a 3D problem into a surface problem and then perform the analysis. Once we have done this particular analysis, we are going to close this one, and we are going to save this particular project file. In the next section, you are going to see how you can use Ansys Workbench in order to perform analysis on 1D problems or different structural problems, say like beams, and how to draw SFD BMD diagrams using Ansys Workbench. Thank you.